All right. All right. Today we're going to look at some sedimentary structures and talk a little bit about how they formed. We'll start with one of the most common. These are bedding planes or beds. And just about every sedimentary rock is going to have bedding planes. They occur sometimes when sedimentation pauses or stops for a little bit. Sometimes they're related to changes in the amount of energy in the environment, how fast currents are flowing and such. Sometimes differences in grain size, differences in grain composition. There's a lot of different things that can cause changes in the sediments and cause beds to appear. So this is just one outcrop that shows bedding. This is at Root River Park here in Olmsted County. And let's look at another example. This is some bedding from an outcrop along Route 61 in northern Minnesota along the North Shore. And you can see some very nice layers within this bed. And there's a lot of other interesting sedimentary structures at this outcrop, so we'll come back to that one. That's my daughter for scale there. And then a little bit closer to home, this is from Whitewater State Park, and this shows ripple marks. So you can see some ripple marks in this limestone that's at the park there. And so ripple marks are another common feature, and they occur in a couple of different settings. They could be wave ripples, in which case they would be symmetrical, and these look like they are wave ripples because they look like they are symmetrical. Or they can be current ripples. Current ripples happen when a current flows along, and those are asymmetrical. Here's an example of current ripples. This is from the outcrop in northern Minnesota along Route 61, and you can see one side is steeper than the other. And so you can tell then which direction the material was flowing. So it was flowing, in this case, from top to bottom. Continuing on here, same outcrop, larger example of the ripple marks in that location. So great ripple marks in that area. Another sedimentary structure that can be found is graded bedding. And so here you can see some graded beds. These are from the Lake Vermilion Formation. And you can see that they are coarser on the bottom of the bed, and then they get finer and finer as you go up the bed here. And so these are very good indicators of which direction was up. That's called a geopetal indicator. And this is the same image, but they've superimposed some arrows on here to show you which way up was. So as a current flows along, at first it's flowing very fast, and it can only deposit the largest grains. And as the current slows down, smaller and smaller grains can then be deposited. And when the current stops, then just the finest mud can be draped on top and will eventually settle out of the water column. And then another current will come along after. And so you'll have a sequence of these coarse to fine, graded beds that continue up the sequence. Here's another sedimentary feature. This is in the Jordan sandstone here in Minnesota, and these are ripup clasts. And what you can see here, these are chunks of the sediment that were ripped up from another location and redeposited a little further along. So you have sometimes big chunks, small chunks, and that's an indication of a very high energy environment where there was some erosion and then redeposition of the same material. So that's a good sedimentary feature. These are cross beds, and cross beds are one of my favorites. They're pretty spectacular when you can see these angled beds like this coming up and then just truncating against another, and then some going in the other direction. And these can also help you to find out what direction the currents were flowing. And these are formed either from ripples or dunes or other features that were moving along the sediment surface here, being deposited by the whatever thing was depositing it, either wind or more likely water depositing these. And so they just build up one layer upon another, but at an angle. So those are cross beds. Here's some more cross beds. This is in the Mount Simon Formation, and you can see these nice little angled cross beds. Sometimes these are called herringbone because they kind of have this herringbone look to them. But or cut and fill is another term you'll see used for these. So these are very nice little cross beds. And here's another feature that's very important and interesting. These are mud cracks. So when an area dries out and you have the mud that's at the top of the bed dry out, it can crack and later get filled in with other materials that kind of fill in the cracks. And so the mud cracks can get preserved on the tops of the bed. So it's another good indicator of where the top of the bed is, which direction up was. And you can see it really nicely. And this is from that same outcrop in northern Minnesota. And here's another example, same stuff. And you can see very nice mud cracks that were formed in those beds. Here's another feature, another sedimentary structure, and this is called bioturbation. And it's when you have some organism that is going to churn up the sediments. And in this case, it's some type of worm that has formed these little burrows. So worm burrows are a common form of bioturbation. And that's a few of them anyway. So hopefully that was informative.